All right. This is a current carrying conductor, which means it's not a bar magnet. It's a wire. It's a wire that carries current through it. And when the current flows in the same direction, there's a magnetic force of attraction between the two conductors. And when it flows in the opposite direction, they repel each other. So these are basically two wires, and we have to just remember what this symbol looks like. And we remember, we think about sort of an arrow. So we're playing darts or shooting bows and arrows, and they have a feather at the end, and that feather makes a bit of a cross. And at the tip, we have just a dot if it's going through, and at the end we have a cross. So I'm just using that as a way to kind of visually remember what's going on here. So what I think of is here is the arrow coming out at me. So it's traveling out of this page directly towards me, and here it is traveling into it's traveling into this page. So it has already come through, and the arrows or the feathers went through, right? And now if we think about our magnetic principles, and what we've already learned is that that if we induce a current in a wire or in a current carrying conductor, that movement of electrons is going to induce a magnetic field around that current carrying conductor. So if you follow me, these are this is the magnetic field, and that magnetic field, those are called magnetic flux lines, and we have this symbol for magnetic flux lines. We know already that magnetic flux lines have a direction. So we take our right hand and we put our thumb in the direction that the electrons traveled in conventional electron current flow. And it's traveling out of the page here. So I'm over here and I have my thumb up saying out of the page, and my fingers are turning around. My thumb is facing up to the sky, and my fingers are turning around, and they're showing me my fingers are going this way. So they're showing me the direction of this magnetic flux, because one of our principles of magnetism is that magnetic flux, magnetic field lines have a direction. Similarly, on this side, we're going into the page. So my thumb is pointed down to the ground, and my fingers are saying, oh, this field line is going this way. So what we have here is we have magnetic field lines going this way, but then we have magnetic field lines going this way. When I take that to the extreme and they try to join, we can see that they do not join. And here, down here, it's very clear that the directions are opposite. And another one of our principles of magnetism says that opposites repel. Therefore, these two conductors are going to repel each other, and we get this repulsion. But that's different than this next one. In this next one, here's this arrow's coming out of the page. This arrow's coming out of the page. My thumb is pointing way up to the sky because I'm doing the right hand rule of current carrying conductors. My fingers are wrapping around, and they're saying, oh, the flux goes this way. The flux goes this way. And I'm going to take that to the extreme again, right? Let me take it to the extreme. This is almost the extreme. Looks opposite. Let me take it to even more of, oops, it was opposite. Let me see. Here we go. I'm taking it to an extreme. I still can't really tell if that's the same direction. Let me take it to even more of an extreme like I did here. I take it to more of an extreme. It's going this way, and this one's going this way from my right hand rule. These are the same. They're going to work together. They're going to join. And same with this one down here. These are both going into the page. Now I have my thumb pointing down to the ground because I'm doing the right-hand rule of a current carrying conductor. My fingers curl around that thumb. My fingers are going in this direction, and my fingers are going in this direction. And I'm going to take that into an extreme case. Here's an almost extreme case. Still can't tell if it's the same direction. Here's a very extreme case. It's the same direction. This is the same direction. They are working together. So they are forming attraction. Attraction. So how do we know that they actually attract? We think back to another principle of magnetism that says magnetic lines of flux like to be as short as possible. So these formed together, good, because they were in the same direction. They formed together because they're in the same direction, sure. But then we have to remember why they are going to attract. Why are they going to attract? Because flux lines tend to be as short as possible. And that's the reason why. And Richard Feynman says that's not like an elastic band. But you know what? It's kind of like an elastic band. Because now these green things that I just highlighted that are in the same direction and make attraction happen between two current carrying conductors, they want to be as short as possible, kind of as if you had stretched them into an elastic band. Now they're going to pull together. And what they're going to do is they're going to pull those current carrying conductors together, just like you're familiar with a bar magnet getting pulled together.